So here I will be using the hist function in R to produce very nice histograms. As you probably know, histograms are a graphical representation of the distribution of a particular variable. In particular, this chart will contain columns, and the size of each column will be proportional to the frequency of observations within each range that we define. So let's begin by getting into this website and download person_ids.csv. So in order to read this, I'll put it in here, but you can put it wherever you want. So after you run read.csv, you can see that here I have a person ID, which is a number, then I have a name, and then I have a place where each person was born, and then I have the age. So here, an initial analysis would be to run a summary on person IDs. So this is kind of useful because I can see for the age that the minimum is 14 years old, the maximum is 91 years old. I can see that the median is 28. So certainly the majority of the people here are reasonably young, and it is also important to see that we do have quite an interesting amount of people in the third quartile, which is 50 years old. So it means that between 50 years old and 28 years old, there is a relevant amount of people there. But certainly it's hard to imagine how this looks like in a visual way. So that's where the histogram appears. So the hist function is included in R. You don't need any special package. And the first variable that you need to specify is which will be the data you will be using. So in my case, I will be using person_IDs, age. Then I need to, or I can specify a title. This is not necessary, but in my case, I'll be very specific about the title of my chart. I want it to be age histogram. So you could omit this part. The other part I will be using is the freq equals to false. You can omit this part as well. This will tell R that I don't want to work with frequencies, but I want to work with densities. So at the end, the size of the histogram will sum up to 1. This is because I'm putting freq equals to false. Then I'm specifying the color, which in my case I want it to be red, and then I want R to put the axis. So this is not necessary because axis is true by default, but you could put it false here. So this is just to show you how this looks like. So if you run this, you have the very famous histogram. This is kind of horrible. So here we have a much clearer representation of our data, and we can see in a very visual way that the majority of the people are located between 20 to 30 years old. We can see that then there is an interesting amount of people between 40 and 45. We don't have people between 60 and 70, and we have a very few people over 70 years old. But this is a much nicer representation of our data. You can see that here we have a density, and this area will sum up to 1. Now we could do the same thing, but using different parameters, so we can explore how that affects our results. So I will be using freq equals to true. That will be the first change, and the other change will be placing in here will be a break. So I will tell R that I want to break the histogram at these specific points, 0, 20, 50, and 100. Here the maximum number that you put here should be larger than the maximum that you have here. So if I had put here 90, that will throw an error because here I have Lisa, which is 91 years old. So I would be causing an error. So if we run this, you can see that this histogram looks quite horrible because I probably specified those breaks in a very inefficient way, but nevertheless you can see that here the y-axis changed. Now I don't have a density anymore, I have a frequency. So these are amount of cases, amount of people. So 15 is 15 observations. Certainly this is interesting. Of course you can see that these black lines fall exactly where instructed are, so this is 20 and 50. So sometimes this happens when you have a histogram and you want to be very specific about when you want those breaks. But in general, I must admit that when we draw histograms, we typically use the default bins that are computed by R. Anyway, and finally I will show you one thing. Sometimes you might want to draw a histogram or to get a histogram, but not because you want to look into the chart, but because you want to access what are the bins, what are the amount of what is the frequency for each bin, what's the density, and so on. So you can have a whole bunch of things there. The way to do this is by specifying plot equals to false. Here you can see it's false, and I will be storing this in the Q variable. So if I run this, you can see that, ouch. So if I run this throws obviously an error, and the reason for that is because there are certain parameters that cannot be used when I am not producing a chart, when I'm not plotting it. This is because plot equals to false. So the reason to fix that is by specifying this equals to false and then executing this, and here you can see that in Q I have everything that I wanted. I have the breaks that were determined optimally by R, or automatically by R. I have the counts for every bin, I have the density that was estimated for every bin, I have the midpoints for every bin, I have the variable that was used for this, it was person underscore ID's age. I have a flag that tells me whether this histogram used equidistant bins or not. In this case this is true because they're all separated by 10. So here I can access everything that I want, and in fact I can just do Q breaks, and here I can retrieve a list of all the breaks that were used in the histogram.